So you can see the MSEEL project there, and it's essentially a long-term collaborative lab. That's how I see it, and for various experiments in both more efficient production and minimizing environmental impacts. So all that. Essentially, I'll just skip through this, and you can see that there's been huge revolution in terms of unconventionals. It's changed everything. The United States, from an energy importer, will be an energy exporter probably next year. We will export more energy. We'll put out more energy than we consume. And that is a huge change. And really all this has come about by smart drilling. The computer revolution, a drilling rig, and the bottom line there, a drilling rig is nothing more than a computer with a drill bit on the end. We're talking about petabytes of data, and that's one of the challenges of this project. We'll be dealing with huge, huge quantities of data. And I just thought we'd bring it back to West Virginia. 2/3 of the gas in the state of West Virginia is made out of comes from the Marcellus. You can see our conventional gas has been producing since the 19th century, and but it's been pretty flat. It's been an explosion. The thing to realize is that comes out of about 4% of our wells, probably about 1/2 of 1% of our locations. These are very, very different kinds of wells, and it changes everything. Same thing on the liquids. We're probably over 60% of the liquids in the state are produced out of the Marcellus, mainly in the Panhandle, down through Tyler County. And you can see that explosion. And that, again, is out of a very, very small percentage of the wells. You know, we have many, many thousands of traditional wells, and just a relatively small number of Marcellus shale wells. What's driven that is efficiency. This is EIA numbers. Essentially, you can see that the rig count's gone down, but the production keeps going up. And there's been a 45% annual improvement in production. A well produced 45% more every year, and that's how it's been done. So, same thing on the liquids. So, really come down to developing new technologies, monitoring and documenting the impacts, and all of the impacts from both environmental impacts, societal impacts, and that's the whole thing. We have a large crew, and Earl missed about half the people, but in the various places, but involved with this, but looking at various aspects. I never thought I'd be working with a sociologist, but I am. So, and that's good. Where is it? Here's NETL. There's the site, nicely located, and it's very close to campus. This is a picture in 2011 of Northeast Well. You can see Morgantown in the background. They drilled 2 wells to the south, so we have a baseline, I guess you want to call it, as far as production. And talking to Mr. John, it's probably the way that's changed since 2011 is probably night and day, as far as it'd be interesting to see. They will drill 2 wells to the northwest, those 2 center wells. And we will drill an observation well in the center to core it, log it, monitor it. We'll also monitor the pad. And you can just barely see the 2 black wells going down to the southeast. Really, I think what the goal is, as far as I'm concerned, I'm going to take my biases, is the IPs have gone way up, and probably the EURs have gone way up. But we're still only getting 10% of the gas probably out of the ground. I don't know what the percentage recovery, maybe 15, but there's a huge amount of resource that can be extracted, and that if we can improve that, just a small percentage, that's in the order of trillions of cubic feet. So that's one of the goals, but there's a lot of other goals there. And right down to, I think, data acquisition and processing tools, how we're going to process this data, how we're going to keep it. I think companies are swamped with the amount of data that comes in and how to efficiently do that. And so if we can contribute to that. And basically give them results that are achievable and credible and demonstrate those results. I stole this from Dave Cole from Ohio State, but it shows something. We need to know how fluids and gases flow at the nanoscale, and to scale that all the way up to the reservoir scale. That is a tremendous computational effort and experimental effort. This shows the frac design for 2011. You can see that we're getting ready for 2 wells. You can see both of the separators there. So, and one thing is containment. This is not their well. This is another well up in Pennsylvania, actually. But to try to get this for it sufficiently down into that black interval, the Marcellus. Getting outside of that Marcellus does you no good whatsoever. And to contain that fracture stimulation. And we're going to have real-time completions where they can change the ability to fracture stimulate from stage 1 to stage 30 and to move along the well and to optimize that. We're also going to have the ability that we're going to put fiber optics in these wells and the ability to monitor those wells to see which stage, which perf, which cluster is providing the gas. And then we'll also monitor that for over 5 years, every other month, and to see how that decays through time. Many of those fractures will probably close, and it'll be an interesting thing to see. And so that. Also look at the surface, water, liquids, air, traffic, all those aspects there. This is where the controversy, it is close to the water plant across the river. And you can see the location. Also the operations, we're going to use a biofuel mixture. And this should 60-40. That'll take down the amount of diesel trucks hauling diesel. Also, it should take down the emissions tremendously. And look at the societal impacts. As far as the economic impacts, we're going to know where people live, and we can beautiful social experiments. So with that, I'll be quiet. But that's sort of the 10,000-foot view of this thing. And it's a big opportunity. It'll be interesting to see how this progresses over 5 years.
Thank you for having me here this afternoon. Excuse me. When Trina asked me to talk, I wasn't really sure what to talk about, so I thought I'd talk about rainbows, pots of gold, and leprechauns. And so what I decided I'd talk about is where the money is, which I guess is the pot of gold and what everybody wants to know about. So a little bit about what our future budgets are going to be at NETL and Natural Gas Technologies program, which our mission is energy, environment, and national security, which is pretty much just buzzwords, I think, that all of our programs are going to say. But it's true. I mean, we're trying to solve some of the energy and environmental problems associated with oil and natural gas. Our funding request in 2016 has 3 key areas. One is environmentally prudent development. This supports our MOU with the Department of Interior and with EPA, and is looking at developing safe and prudent unconventional oil and gas resources. This includes not just looking at the environment directly and environmental impacts directly, but also, as Tim mentioned, getting more for a particular well or a particular pad, getting more of the resource out so that you're getting more bang for the buck, if you will. The second area is emissions reductions from midstream natural gas infrastructure. And this is looking at new technologies to reduce emissions midstream from transmission, distribution, and storage facilities. This is actually a program that we had at NETL up until, I believe, 2004 or 5, and then it was discontinued, and now it's back, which is something that happens often with the government. things go away and then they come back. The third is emissions quantification for natural gas infrastructure. This is looking at just quantifying the emissions coming out of the full life cycle of natural gas. A little bit more on each of these. I don't know why that did. There we go. For environmentally prudent development, there are two key areas: subsurface engineering and water energy. The water energy is what it has been referred to in the past as the water energy nexus, and it's been around for quite a while, and it's now getting more traction. And subsurface engineering, I'll talk a little bit more about. It's referred to as subtier. And combined, those two programs are looking at $19 million. And this is all from oil and gas. There are other programs that might be contributing, in particular, to the sub-tier and the water and energy nexus. The midstream natural gas infrastructure is looking at $15 million. This is our request, by the way, so it's not guaranteed. And as I said, it builds on a past program that NETL had in the natural gas infrastructure program. A lot of the technologies we worked on in that area had to do with detecting pipe defects and resolving pipe defects, if you will, correcting them and curing them, if you will. The third area has to do with, as I said, emissions, quantification of full life cycle of natural gas, and that has a budget of $10 million. We currently have a portfolio with, at a minimum, half a dozen emissions quantification projects, as well as ARPA-E just announced within the last 3 or 4 months $30 million of emissions quantification. So it's an area that has, again, is getting a lot of traction, and it's basically helping to build the sort of the climate models and looking at how methane emissions and other emissions from oil and gas industry are contributing to the greenhouse gases. Just wanted to also point out a little bit about what my program has done with WVU and how you are contributing to the research. This just is a snapshot of what's going on right now, and just in the oil and gas division, my division. There's a lot of WVU professors that are working with sequestration or with geothermal, whatnot, but these are just some projects and principal investigators from WVU that we're working with. We've got the MSEEL project that we're talking about today. There are some air impacts with Dr. Nix, where he's looking at different equipment, natural gas versus diesel, and trying to retrofit the engines. Fault reactivation during hydrofracking, Dr. Fathi. Dr. Sharma has been doing a lot of our ISO work with the geochemistry, and we've got Dr. McCauley with the emissions measurement and monitoring, and Dr. Surwarden, who's also looking at fracture propagation and ground motion. Those are split out between our extramural projects and our in-house ORD research. So I said I wanted to talk a little bit more about the subtier. This is a new initiative that has received seed funding and some new projects that were just awarded with $1.6 million of seed funding from EERE, the geothermal program in particular, and FE sequestration in particular, not the oil and gas program. But as I showed you, our budget in 2016 does provide money for this initiative. And there is money in the 2015 budget to the tune of $6 million for sub-tier projects. So if you're interested, keep an eye on that. That might be an area that you would be able to play in. These are some of the pillars that the sub-tier program is looking at. They include many aspects that the MSEEL project can and will be addressing intelligent wellbore systems, subsurface stress and induced seismicity, permeability manipulation, and new subsurface signals, all areas that I believe Tim is looking at or will be looking at. Just real quickly, the next slide is a companion project that we're doing with GTI. This is one of our other field projects, field laboratory projects, which basically our field laboratory projects will support subtier. This Shell Oil most likely will be the industry partner. We're still in negotiations with this, by the way. And they're looking at frac fluid tracers, tag proppants, and doing a slant well coring through the frac zone. And they will be at the Wolf Trap Formation in the Permian Basin, most likely. So that's really that's all I had.
It's certainly a pleasure to be here. It's unusual to sit and talk, but I understand the format today, so I'll do my best. I'm a person that tends to move around and use their hands a lot when I talk, so you have to excuse the fidgeting that you're about to witness for the next few minutes. But it's good to be here. It's good to be anywhere inside on a day like today, I think. But I'm proud to be here, first of all, as a West Virginia alum, as a West Virginian, and as part of Northeast Natural Energy. The intro pretty well set it up. Our company is Appalachian-based. We're a group of professionals. I think of us as accomplished professionals that have the good fortune, the blessing really to be able to do what we want to do, where we want to do it. We are so fortunate to be here in Appalachia with the unconventional potential that's here underlying this area, from the Marcellus Shale as well as the Utica Shale, and there are some other shales over the next few years that you're going to hear more about. But Appalachia has certainly come to the front as far as a supply source for the United States and hopefully for the world as we go forward. I mentioned that our company was formed in 2009, so we're relatively young as a company. You can see for me, I'm not relatively young, but our company is only 5.5 years old. The core group of the founding partners of our company, we've worked together since the early 80s. I started with Columbia Gas Transmission in 1981 in Charleston, West Virginia. So our team has been together for quite a while. We've had good success in Appalachia over the years. We've focused a lot on deep exploration as a team, and certainly over the last few years, we've like everyone else, we've caught shale fever, and we're very intent on the development of the unconventional resources here in Appalachia. I will mention that there was a bit of a spoiler alert. I do have a video that I'm going to show in a few minutes, and it's just a kind of a primer, I think, and it may not be useful to everyone, but I think it will be helpful as we talk specifically about some of the research that will be undertaken at the Morgantown Industrial Park, that we look at that video in a moment. So I'll mention that. Try to be coordinated here with the slides. A little bit more about our company. We currently have approximately 50,000 acres under lease in Appalachia. 22,000 or so acres in Pennsylvania in Armstrong and Clarion counties, PA. And then we have a little over 20,000 acres here in Monongalia County. We refer to that as our Mon prospect area. You can see from the slide that we've had some activity over the last few years. Our momentum is certainly building. In the Mon County area, we drilled 4 wells in 2011, 2 of which were on the Morgantown Industrial Park site, the site of the laboratory, and 2 in the Blacksville area in Cass district Clay district of Mon County. Then we drilled 3 wells in 2013. Last year we drilled 7, all in Mon County, and then we expect to drill 17 wells this year in Mon County, including the 2 research wells on the Morgantown Industrial Park site. We also, in our Pennsylvania properties, we've drilled 2 wells in 2011, 2013, and 2015. Before I go much further, I tend to run on when I talk about the asset, but I'm happy today that we've got 2 of our folks with us, and this is it's flattering for me to be introduced as a founder of a company and to set up here as someone that has a position of leadership in the company, but I can assure you that nothing happens by yourself in a business like this. And what we've been able to do with our reputation, I think, in Appalachia is that we've been able to attract only the best people to be a part of our team. We have two of them here today, and I want to be sure that I introduce those to you. As a small company, we do many different things, so I'll just give primary responsibilities for these two guys, but they do much more than this. Jay Hewitt is with us, and Jay is he's in charge of drilling, as well as many other things. You'll see Jay take a very active and leadership role in this project as we go forward on the Morgantown Industrial Park site. Also have Zach Arnold with us, who's our General Manager of Operations. So I'm very pleased that those gentlemen are here. I'm introducing them now because if there are very difficult questions after this, those will be the two guys that I'm hopeful that will be able to step up and answer those. I was given really a kind of a limited scope of what to talk about today, and one of the main things that was communicated to me to try to reference for the group is, why are you doing this? Why would Northeast Natural Energy undertake a research project with West Virginia University, with Ohio State University, with the U.S. Department of Energy? And so on this slide, I've tried to capture what I think are the most important points. And the first bullet, to identify more efficient and effective ways to drill, complete, and do all those kind of things. That's a key phrase. But what I think about is that our industry, in order to prosper, in order to survive, has to be about continuous improvement. And we do everything that we can every day at our company to continue to improve, to continue to find better ways to do what we've been doing. And I saw this project as a way to accelerate or amplify that effort. So that really is the key answer as to why we're doing this. But we also believe that the results of this project will be widely distributed and well recognized with the industry. So anything that we can do to demonstrate best management practices is a key, I think, not just for our company, but for all the other folks that are looking at the work that happens at the Morgantown Industrial Park site. And certainly this is personal for me, but I think it's shared by the team. We look forward to expanding and improving our relationship with West Virginia University. One of the things I like to say when I'm talking, particularly to landowners in this area, we're from here. And that's a key for us. That's a brand or a trademark. And so it's important to us to be active in the community. It's important for us to be recognized as someone that you want in your community. And so that's another reason that I see, another value that I see for our company to be a part of this research project. And then the last bullet, again, is a way of restating some of these things, but I do want to emphasize that any operator, particularly our company, we're all about safety and we're all about not harming the environment. So that's a key for us too. As we look at the different tenets of this project, as we look at the different things that will be measured and monitored and observed and written about, we see this as an opportunity not just for our company but for our industry to step forward and to show that we're committed to doing things the right way. We can't survive if we don't do things the right way. So now here's the video, and I have to admit this is it's not plagiarized. I pulled it from the website of I believe it's Marathon's video that we're about to look at, but I think it's useful.
Geologists have known for years that substantial deposits of oil and natural gas are trapped in deep shale formations. These shale reservoirs were created tens of millions of years ago. Around the world today, with modern horizontal drilling techniques and hydraulic fracturing, the trapped oil and natural gas in these shale reservoirs is being safely and efficiently produced, gathered, and distributed to customers. Let's look at the drilling and completion process of a typical oil and natural gas well. Shale reservoirs are usually 1 mile or more below the surface, well below any underground source of drinking water, which is typically no more than 300 to 1,000 feet below the surface. Additionally, steel pipes, called casing, cemented in place, provide a multi-layered barrier to protect freshwater aquifers. During the past 60 years, the oil and gas industry has conducted fracture stimulations in over 1 million wells worldwide. The initial steps are the same as for any conventional well. A hole is drilled straight down using freshwater-based fluids, which cools the drill bit, carries the rock cuttings back to the surface, and stabilizes the wall of the well bore. Once the hole extends below the deepest freshwater aquifer, the drill pipe is removed and replaced with steel pipe, called surface casing. Next, cement is pumped down the casing. When it reaches the bottom, it is pumped down and then back up between the casing and the borehole wall, creating an impermeable additional protective barrier between the wellbore and any freshwater sources. In some cases, depending on the geology of the area and the depth of the well, additional casing sections may be run and, like surface casing, are then cemented in place to ensure no movement of fluids or gas between those layers and the groundwater sources. What makes drilling for hydrocarbons in a shale formation unique is the necessity to drill horizontally. Vertical drilling continues to a depth called the kickoff point. This is where the wellbore begins curving to become horizontal. One of the advantages of horizontal drilling is that it's possible to drill several wells from only one drilling pad, minimizing the impact to the surface environment. When the targeted distance is reached, the drill pipe is removed and additional steel casing is inserted through the full length of the wellbore. Once again, the casing is cemented in place. For some horizontal developments, new technology in the form of sliding sleeves and mechanical isolation devices replace cement in the creation of isolations along the wellbore. Once the drilling is finished and the final casing has been installed, the drilling rig is removed and preparations are made for the next steps, well completion. The first step in completing a well is the creation of a connection between the final casing and the reservoir rock. This consists of lowering a specialized tool called a perforating gun, which is equipped with shaped explosive charges, down to the rock layer containing oil or natural gas. This perforating gun is then fired, which creates holes through the casing, cement, and into the target rock. These perforating holes connect the reservoir and the wellbore. Since these perforations are only a few inches long and are performed more than a mile underground, the entire process is imperceptible on the surface. The perforation gun is then removed in preparation for the next step, hydraulic fracturing. The process consists of pumping a mixture of mostly water and sand, plus a few chemicals, under controlled conditions into deep underground reservoir formations. The chemicals are generally for lubrication, to keep bacteria from forming, and help carry the sand. These chemicals typically range in concentrations from 0.1 to 0.5% by volume and help to improve the performance of the stimulation. This stimulation fluid is sent to trucks that pump the fluid into the wellbore and out through the perforations that were noted earlier. This process creates fractures in the oil and gas reservoir rock. The sand in the frac fluid remains in these fractures in the rock and keeps them open when the pump pressure is relieved. This allows the previously trapped oil or natural gas to flow to the wellbore more easily. This initial stimulation segment is then isolated with a specially designed plug, and the perforating guns are used to perforate the next stage. This stage is then hydraulically fractured in the same manner. This process is repeated along the entire horizontal section of the well, which can extend several miles. Once the stimulation is complete, the isolation plugs are drilled out and production begins. Initially water and then natural gas or oil flows into the horizontal casing and up the wellbore. In the course of initial production of the well, approximately 15 to 50% of the fracturing fluid is recovered. This fluid is either recycled to be used on other fracturing operations or safely disposed of according to government regulations. The whole process of developing a well typically takes from 3 to 5 months, a few weeks to prepare the site, 4 to 6 weeks to drill the well, and then 1 to 3 months of completion activities, which includes 1 to 7 days of stimulation. But this 3 to 5 month investment can result in a well that will produce oil or natural gas for 20 to 40 years or more. When all of the oil or
Cut it off a little bit soon there, but it's an interesting use of YouTube this afternoon. I probably didn't expect we were going to do a YouTube when you came in today, but I do appreciate the Marathon website and the opportunity to use that video. I think it's a helpful tool as we talk a little bit more about some of the work that we're going to do on the Morgantown Industrial Park site. One quick editorial comment I noticed as we clicked away from that video. The author of that material estimated that the wells would produce for 20 to 40 years. We're very early still in development of unconventional shale resources through horizontal drilling. So I think it's a little early to estimate how long these wells might last. I would comment that some of the companies that I've worked for in the past, primarily Columbia, had many vertical shale wells that produced well in excess of 100 years. So personally, I don't see any reason to expect these horizontal wells to produce any less time than that. This is a very long-lasting resource. Another editorial comment is that when we put our company together in 2009, we were hopeful. I had a couple names in mind, and both of them had to do with bridge fuel or bridge energy. Because the vision was that natural gas is the bridge fuel to a renewable future for our country and the world. Unfortunately, I couldn't find a unique name that had bridge fuel or bridge energy in it, so we settled for natural energy, which I think is still a very good name. And in order to make that unique, we called it Northeast Natural Energy, which gave us a geographic reference as well. So to talk a little bit more then about the project itself in the Morgantown Industrial Park, there are really 7 areas of focus from my standpoint as to what I would expect to see out of this research project. The top of the list is what we would think of as environmental monitoring. That we'll go through in some detail as to what some of that will be, but we will be testing the effects, the impact in and around the area that we're working as to air and water. So there'll be some monitoring of that. We'll do some coring work. Tim talked about our science well, that we will drill a nearby well that we'll take a whole core and we'll evaluate that. I'll talk a little bit more about that as we go through it. Geosteering, we're going to do some work on our MWD, which is measurement while drilling. One of the things that I was amused by when I looked at the video, as you saw the horizontal portion of the well, it was very straight, but you could see the undulation of the gray shale-like rock that was depicted in the video. I can assure you that our wells are not straight. We do everything we can to pinpoint a specific interval in the Marcellus and stay in that interval as we drill through it. So some of the research that we will do and some of the science that will be applied has to do with the steering mechanisms. Horizontal logging, this is something that as an industry we generally don't do. It's a very expensive proposition to push a logging tool out into the horizontal portion of the hole to retrieve data and then pull it back. So it's a benefit to our company that we'll be able to do some horizontal logging on this MIP site. We'll do some stimulation modeling to help us monitor and predict the effectiveness of the stimulation designs that we'll be using. Microseismic, I'll talk a little bit about that in one of the slides. That's a key tool. Tim talked about that. That helps us map the impact or the effect of the stimulation. And then we've got some exciting things that we look forward to doing with fiber in the wellbore to do some production monitoring. I mentioned the environmental work. We will be doing air emission monitoring at the site. We'll have equipment set up adjacent to the pad, maybe at the WVU laundry, some other places in the area that will help us monitor the air impact. We'll do surface and flowback testing. This will be done by an outside lab. I don't believe we've determined yet just who that will be doing that work. There will be noise monitoring conducted at the site. Equipment will be set up around the perimeter of the pad so that we can adequately measure the impact from a noise standpoint. And then, of course, there'll be groundwater monitoring. We do that routinely in our industry. We test water wells within, I believe, 1,500 feet of a well in West Virginia. I think that's a requirement. Our company goes another 500 feet beyond that so that we test all water wells within 2,000 feet in the state. And we believe that the learnings from all of this type of monitoring will demonstrate the efficiencies of current practices, and it will be there for us to see what efficiencies or what is less than efficient in what we're doing. And I would be hopeful that this would result, these key learnings would result in potential improvements, not just for us but for the industry as we see more information, more data on what we're doing. Coring, we'll cut a whole core through the Marcellus. We'll actually do cores from above the Marcellus to below it. We'll do some sidewall coring well above and well below the Marcellus. One of the things that I noticed on one of Tim's slides that I thought was very important when you're thinking about the stimulation work we do in the Marcellus, we have very well-defined barriers above the Marcellus, the Tully limestone. The Marcellus sits just on top of the Onondaga limestone below us. So oftentimes when you talk to folks about stimulation design, they'll equate that to kind of bowling with bumpers on, because you've got impermeable zones above you and below you, which will do what you need to do to keep the frac activity within the Marcellus, but the Marcellus is still pretty thick. So we're being very specific. We want our fracs to not go all through the Marcellus. We want it to be in a very specific interval within the Marcellus. Here's some pictures of the cores. We'll take whole cores. They'll be about 4.5 inches in diameter. Many people that haven't had the opportunity to be on a drill site to see the work that we do are often surprised by the relatively small diameter of the holes that we drill. We'll drill through the Marcellus Shale a hole that's 8.5 inches in diameter, about the size of a bowling ball. And then inside that hole we'll place 5.5-inch casing. That will be the production string that you saw referenced in the video. But when we do the coring work in the vertical science well nearby, we will cut about a 4-inch core, and that's depicted in the picture here. That's what the whole cores will look like when they come out of the hole. Geosteering, it's hard to see much from the visual on the slide, but we have, particularly in our work in Monongalia County, we've identified a 3 to 5 foot interval within the Marcellus that is where we want the wellbore to be placed. And we're able to identify where we are within the Marcellus as we drill by having real-time feedback in the form of gamma ray signal that will give us a signature, that we're looking for to stay in a high organic area within the Marcellus. And that's our guide as we steer through the Marcellus. So we are very effective, over 90%, maybe closer to 99% effective in being in that 3 to 5 foot interval. And we mentioned about key learnings and key developments. If you look back at the work that the industry did as recently as 2011, those type of results were unheard of. And I think we're among the best, even though we're small, we're among the best at placing the wellbore within the formation, but the entire industry has stepped forward quite a bit in their ability to be more precise in how that wellbore is placed. Horizontal logging, I mentioned that we will pull a log through the Marcellus. This will give us information that will be critical as we look at the results of the stimulation, as we consider future stimulations by our company. And again, ultimately this information will become public. So I see this as something that will have a benefit to Northeast Natural Energy, to Ohio State, to West Virginia University, but then ultimately to the industry as these results are made more known. Stimulation modeling, it's really more of the same in that we'll take the pressure information, the volume information from what we pump into the wellbore, and then we'll compare that or look at that in conjunction with the production information that comes from this, coordinate all of that as we kind of use the background of the information that we'll obtain from the logs to be able to determine what efficiency we saw in the work that we're conducting on the Morgantown Industrial Park site. An old joke that these guys have heard a bunch, this isn't rocket science, it's rock science. But it is science. And we continue to find better ways to place our wellbores. We continue to find better ways to stimulate the wells in order to increase productivity. A nice visual that shows the effect of some of the modeling that's done in the past. You can see about I think that's about a 150-foot interval that's highlighted there as the result of the frac job. We'll use microseismic from a nearby well to monitor, we call them events, frac events within the Marcellus Shale. Here's a nice picture, I think, that shows the results. I can't point very well. My hands shake a lot, but that's the monitoring well, the science well, and then you can see the colored dots. Each of those different colors would be the various frac stages that we would undertake within the productive well. The microseismic will allow us to map the effects of the seismic or of the stimulation work. Production monitoring, we will be using fiber cables in these wells that will allow us to gain data. I think this is really the first time in Appalachia that this has been done. So we're excited to get constant feedback in the formation regarding the production from these wells, pressure, volumes, and temperature. Here's a nice picture of how the fibers will be attached to the casing. A repeat slide. I tried to be clear when I talked to you at the beginning. This is important to us because of who we are, where we're from. We want to be associated with West Virginia University. We want to be associated with Ohio State. We want to be associated with the USDOE. We want to be recognized as a company that is all about continuous improvement. And we're proud of what we do, and we're proud to be able to share it with the folks that will be working alongside us. So I think I've used my allotted time, so I'll be quiet now and we'll go to questions.
Thank you, Mike. And we have
Thank you.
we have time for some questions for any of the panelists.
Mike, you illustrated that some of the horizontal drilling. In some instances, I've heard that they use what's called a pinnate pattern to get more penetration underground. Have you tried that kind of technology?
I'm familiar with the pinnate work in coal bed formations, but I've not seen the pinnate used in either the Marcellus or any of the shales around here yet. Jay or Zach, have you guys seen any of that?
I've not seen that from any other company. Usually with these, you're trying to stick with a certain azimuth.
So what I envision as we look at our pads, it was mentioned earlier by Tim, we are using one site to drill many wells, maybe as many as 10 Marcellus wells from a single pad, maybe as many as 10 Upper Devonian wells from that pad, and ultimately maybe even 10 Utica wells. But the designs are generally pitchfork-like in that they all are along a similar azimuth after you've gotten onto that plane. But I've not seen pinnates used in the shales yet.
So then I'm assuming that you'll also do quite a bit of frac water quality and flowback water quality to see the variability. Well, can you do frac water?
No, we can't get the water at different stages, but we'll get the water at the surface, no. But we'll get temperature, and you get temperature and noise out of fiber. So we can get how much water is coming out of or how much gas is coming out of each stage.
But you're not taking water quality data on a stage for each stage of the frac?
The fiber will not be able to do that.
No, but you can take water samples.
Because you can't isolate it, because it'll be all open. We won't have any way to isolate the different stages.
We start kind of at the toe, the furthest in, and we'll drill out that first plug and then work our way out. So we'll keep a balance as we go through that drill out process. We call it a barrel in, a barrel out approach, so that we maintain equilibrium. And then as we begin to bring that flow back to the surface and begin to prepare to produce gas, then that fluid's commingled. So there's not, I don't believe there's an effective way to test stage by stage fluid.
Well, I'm trying to think. We will get flow back through time. So you get the first stage, you get some of the flow back, second stage, but then, as they keep backing up, it's all going to get mixed together.
But you could analyze the frac water going down hole for the frac.
We will take the analysis of the water going in and the analysis of the water coming out.
Other questions?
Where's
Could
the
you
location?
speak up so we can hear on
Yeah,
the video?
where's the location of the science well with respect to the lateral?
Oh, it was on that one slide. It's right in between the two laterals.
Okay.
And it's right about where, a little bit beyond where they're going to land. So we can, our microseismic, Jeff is a geophysicist, so I'm thinking we'll have microseismic coverage almost all of one well and about 90% of the other.
About 1,500 foot down the lateral and 750 foot between.
Yeah.
Are you going to do a surface array in addition to?
No, just downhole.
I have a request when we get some answers from our technical experts in the audience, if you guys wouldn't mind repeating that.
Okay. He is asking for doing a surface array or a vertical array, and we will just do the vertical people have never tried to merge those two things. Plus, we got so much noise at the surface with the it's an industrial park, it's just not going to work very well.
And Jay mentioned it was 1,500 feet down the lateral is the placement of the observation well, and 750 feet perpendicular.
Well, there's 750 between the two wells, so. Okay. Each, okay.
Other questions? Go. The video mentioned between 15 and 50% produced and flow back water. Right. My question is, do you have a target for the amount of produced and flow back water that you want to come back out as well? Is that even, and I don't know, is that even something we control? Part one of my question.
Okay. The question was, do we have a target? And we don't preset any percentage that we expect to recover. As we flow the wells back, we have placed sand in the fractures. So a concern is that we don't bring the fluid back too quickly, because we want that sand to remain where it is. So there's a control element to the flow. And then as the wells begin to produce gas, this is an engineer trying to talk geology a little bit here, so bear with me. In my imagination, downhole, the gas and the water kind of trade places with each other, and the gas gets around the water, and you begin to get more gas and less fluid. But we don't preset any kind of fluid percentage.
I believe the downstream strategies has shown that I think the average for West Virginia is on the order of 7% or 7 to 10. Yeah, and I think that video was, I don't think anyone's producing 50% back. I think that's around that 10% realm. And I would say that the producer wants to not have too much water come back, because that costs money to recycle into the next well and things.
That's part two of my question. With respect to recycling for use of wells versus treatment to the point that it can be discharged, is that a technology that you're going to be looking at, where you can completely clean the water, or be acceptable to discharge back into waterways?
We have some people that are looking at that, and was an experimental, but I believe all this water will probably go to another well and recycled for frack water. But we're going to get water samples, and we're going to do some experiments on treating all the way to where you could dispose of it into, it would be clean, let's put it that way.
Maybe we could also get a comment. So the question involved recycling of the water. I know with the DOE focus on the energy water nexus, there's some discussion of this water usage coming
Water usage, water treatment, and consumption.
So is that of the three projects that...
Well, we have been funding water treatment projects, and actually that portion of our portfolio is coming rapidly to an end, just because we've moved in different directions, not because we've solved the problems per se. But we may find that that's another area that we'll be investing in again in the future as part of this water energy nexus.
I know there's some legislation before Congress to look at some of this recycled water usage, and involves some of our other activities at WVU. I know Paul's been involved in looking at some of this. Any questions?
Since we're on the topic of waste management, is that one of the research objectives? It sounds like there's already talking about fluid treatment. And then is there any specific research or research objectives developed towards waste minimization or some sort of alternative strategies for waste management throughout the production process as part of this?
I think we're going to look at all those, yes, and we're going to characterize the waste, okay? I mean, you got not just the water, you have the cuttings, and we have the, I mean, you can think of the air as being waste too, because you're combusting some material to make energy to drill the well and to frack it. So yes, we're going to look at all those things. What I'm pretty excited about is 2-3 years down the way, the technology is going to be so much different that we can demonstrate it again. This is a unique situation that there will probably be other wells drilled out there, and we can say, hey, let's do it better. I would have loved to use LNG, but we can't get the LNG here. To go to 100% LNG and do away with diesel altogether. And maybe in 2 or 3 years we'll have LNG processes at the rig site. That'd be great.
One of the things too, DOE is looking at, our in-house research is looking at such things as leachate from drill cuttings, and this will provide an opportunity to have samples to do that kind of work. They're also looking at how how microbes affect pond, discharge water and what's going on downhole, and all of these things are this project will provide samples so this type of research can be enhanced and more data can be collected to look at those types of waste issues.
Questions?
Tim, you mentioned the 60-40 biofuel you're going to try to be using, and I have a couple questions related to that. So, does that mean 60% of the time you're going to be using 100% diesel and 40% of the time? Okay, so it's going to be a mixture, 60-40, and those fuels will be combusted at the same time, so it'll always be a 60-40 mixture. Okay.
Yeah, and I think the exciting thing for a producer is the energy equivalent of a MCF of gas. There's about 6 MCF, there's 5.9, I can't do the math, in a barrel of oil. Okay, so 6 times $1 or $2 in MCF is the energy equivalent of a barrel of oil to run your rig. Guess what? It's not quite $12 yet, but we hope it doesn't go that low. But, so it can be a cost efficiency thing, is to use the natural gas at the site. Not to mention you just reduced the number of diesel trucks. I don't know, maybe Jay, how many gallons of diesel one of these operations use? A lot. And that's hauled by essentially a truck out there, and that's a dangerous thing to do. The accidents happen.
Oh yeah, can you talk about the sociological aspects or public health aspects of this project?
Well, we'll document the emissions from here. Economics, we'll get how many people are on site, where they live, what kind of economic regional impact. I mean, you wouldn't call that kind of things. We'll look at the change in the regulatory policy since 2011. I think these guys set the policy in 2011-12.
I think it was the work in 11 that resulted in the new rules being implemented in 12.
So then we'll look at the results of those new rules now, and those new rules are going to have to constantly change because the technology is changing all the time. And so those kinds of things, so that public policy part of it. If you were here in 2011, there was a little bit of sociological impact. It would be interesting to see what it is this time around.
Would mention, I don't think we referred to this as we went through the discussion, but all of the gas from the Morgantown Industrial Park site, all the gas that's been produced to date, all the gas that will be produced from the wells that we're about to drill, is consumed within the city of Morgantown. This is not gas that goes through a pipeline to some other place in the United States. It's consumed here in town.
I always make the comment, it probably replaced 100 wells in Taylor County. So buy local. You can think of it that way. The city was importing a huge amount of gas up from Taylor County or wherever down south, and now we supply our own gas. And then, frankly, that's why they're limited to 2 wells now, is he can only produce what the city can consume.
Robert, any consideration being given to fracking with CO2?
Fracking with CO2?
There has been. We did research in that years and years ago. We haven't reinstituted any program to do that. But there's been talk of doing that and including that in a funding opportunity announcement in the future. We do have our sequestration program that's done some enhanced CO2 flooding, but not CO2 fracking. One of the from my understanding, one of the issues with it is the equipment that it would take to do that, the CO2 fracking, just is not available. So it's not as much an engineering hurdle in the sense of can it be done. It's building that equipment to do that kind of CO2 sand fracking. But it's something that we've talked about internally.
I think one thing this project can do is provide my engineering colleagues with the data to model that kind of stuff. I mean, I don't think we have that detailed data to do a viable model of a CO2 frac. And that could be a very fruitful, research area that we'll have the data to address that we just don't have. Nobody has.
Okay, we have time for one last question.
I just asked this question because I hadn't seen any specific mention of the level of detail available here today, but since there are existing environmental conditions from some of the private property owners in there, is there coordination with them to monitor the groundwater plumes and relative to like environmental investigations relative to deep bedrock? We're just talking a few hundred feet where they have monitoring going on with the contaminant fumes.
Paul is back in the back, but some of the, this is an EPA site, and some of that data is publicly available, and there are ongoing monitoring issues there. I don't know if we've approached them.
Yeah, that was my question. Is there a communication between this research body and EPA?
Well, I think those are under the control of the company there that are monitoring. And I'm looking for Paul to save me back there.
So say a few words on that?
Sure, please.
Yeah.
Got two kinds of regulatory wells. There are the RCRA wells and then there are the circle wells. Circle wells are down along the river on the south side of the property. They're really not down gradient of the wells that we developed. So we have that information publicly available. It's not particularly relevant to this particular project. Most of those wells are very shallow. They're just basically there to make sure that the plastic cover that was put in place during the circle action are still functioning properly. Then you have a series of RCRA wells related to the operations that alien chemicals are using in the north and south plants on the property. Those sites already have a good load of detexes in their wells related to historical operations. So we think those are pretty much founded already within, and it would be pretty difficult to pick up any signal relative to the northeast well relative to what's already showing up in these wells. So we don't think those are good candidates, even though there are a lot of them, and they are monitored on a regular basis for compliance purposes. But we'd much rather see our wells specific to the property. So we immediately downgrade it before we get into this contamination of the old historical site. Remember, this site goes back to the Manhattan Project here. There were several operators doing various things with plastic and other organic compounds on the site ever since.
Okay. Well, let's thank our speakers again on the panel.